Hello, everybody, and welcome to this study guide for the AZ-700 certification. In this video, my goal is to give you a very high-level introduction to the AZ-700 certification exam. Now, this session is going to be fairly short, so you can listen to it while you're eating lunch, maybe you're on the treadmill, maybe you're just spending the last 30 minutes of your workday with some self-education. Whatever the decision is, I hope this will be beneficial for you. Focus of these study points all stem from the stated objectives for the AZ-700 exam, which deals with designing and implementing Microsoft Azure networking solutions. And specifically in this session, I'm going to be focused on the second set of exam objectives. And as the slide points out, this focuses on the designing and implementing of a core networking infrastructure. So let's get right into it. Capabilities of Azure Virtual Networks. So Azure Virtual Networks enable Azure resources to communicate with each other. They allow them to connect out to the internet and also to communicate with your on-premises networks. A couple things that you have to think about when you're designing virtual networks in Azure. First of all, you have to think about the address space. So when you create a virtual network, you have to specify a custom private IP address space using public and private addresses. Azure assigns resources in a virtual network a private IP address from the address space that you assign. So for example, if you deploy a VM in a virtual network with the address space 10.0.0/16, the VM will be assigned a private IP, something like 10.0.0.4. Subnets. So subnets enable you to segment your virtual network into one or more smaller networks and allocate a portion of that virtual network's address space to each subnet. That allows you to deploy Azure resources in a specific subnet, and you can secure those resources within the subnets using what we call network security groups. Regions. Each VNet or virtual network is scoped to a single region or location. However, multiple virtual networks from different regions can be connected together using what's called virtual network peering. So, as you build your network in Azure, it's important to keep in mind these design principles. You want to make sure that you have non-overlapping address spaces. Make sure that your VNet address space doesn't overlap, as an example, with your on-premises organization network ranges. Your subnets should not cover the entire address space of the virtual network. So plan ahead, make sure that you reserve some address space for future growth or future needs. It's also recommended that you have fewer large virtual networks rather than many small virtual networks. That's one way that you can reduce the management overhead associated with many small virtual networks. And lastly, secure your virtual networks by assigning network security groups, or you might see it abbreviated as NSGs, to the subnets that exist within them. Now, public IP addresses. So public IP addresses, as you know, allow internet resources to communicate inbound to Azure resources, and they also allow Azure resources to communicate outbound to internet and other public-facing Azure services. And because of that, public IP addresses are important for cloud deployments. One thing you'll need to understand is, again, there are different SKUs available for public IP addresses. There are basic and standard SKUs, and you need to know what can be done with each. So, as an example, you see here in the diagram there's the option to select either a basic or a standard SKU. Now with the basic SKU public IP addresses can be assigned statically or using dynamic allocation methods like DHCP. A very important thing to remember is that basic IPs are open by default. So it's recommended that you use network security groups to restrict inbound and outbound traffic to your basic SKU public IPs. The basic SKU public IPs can be assigned to any Azure resource that can have a public IP assigned to it. So you're talking about things like a network interface, a VPN gateway, an application gateway, internet-facing load balancers. However, the basic public IP does not support availability zone scenarios. And so for that, you need a standard SKU public IP. So the standard SKU public IP addresses are always assigned or allocated statically. They are never dynamically allocated. In addition, in contrast to the basic public IP, the standard public IP is secure by default. It is closed to inbound traffic. So you have to explicitly allow inbound traffic using a network security group. Standard IP addresses can be assigned to all the things that we mentioned before with the basic SKU, but they can also be assigned to standard SKU public load balancers. That's not possible with the basic SKU. And as mentioned, the standard SKU does support availability zone scenarios. So think about scenarios where you would have to make a decision about whether to use a standard or basic public IP for a given network resource or configuration. Name resolution, or DNS. So public DNS services resolve your host names and IP addresses for resources or services that are accessible over the internet. So think about like a web server. You may have www.contoso.com, and there's an IP address behind that. DNS is what makes that translation between the name that's easy to remember and the IP address, which is not easy to remember. Azure DNS is a hosting service for DNS domains that provides name resolution using the Microsoft Azure infrastructure. So in Azure DNS, you can create address records manually within relevant zones. So the records that you're most frequently going to be using are things like your host records, your A records, alias records for CNAME, right? Now, you don't have to own a domain to create a DNS zone with that domain name in Azure DNS. So you can create a domain name in Azure DNS for a domain that you don't own. However, you do need to own the domain if you want to configure the domain. So there's not a whole lot of value in being able to create a DNS zone and not be able to configure it, but there may be scenarios where that's needed. Now, while you can't use Azure DNS to actually buy a domain name, you can buy a domain name by using app service domains, which is an Azure capability, or you can go through a third-party domain name registrar, something like GoDaddy. Your domains can then be hosted in Azure DNS for record management purposes. And as a side point, they would also be, you'd also be able to protect them using Microsoft Defender for DNS. When you delegate a domain to Azure DNS, you have to use the name servers provided by Azure DNS, the ones that you see highlighted here in the red box. So you should use all 4 of these. Azure Private DNS provides a DNS service to manage and resolve domain names in a virtual network without the need for a custom DNS solution. So by using private DNS zones, you can use your own custom domain names rather than the Azure provided names that are available today. So those might be names that you don't necessarily want to use. You may want to use a custom domain name, and that's what Azure DNS allows you to do. Another very important capability with Azure DNS is auto registration. So the Azure DNS Private Zones auto registration feature manages DNS records for virtual machines that are deployed in a virtual network. So when you link a virtual network with a private DNS zone with that auto registration setting enabled, a DNS record will get created for each virtual machine deployed in the virtual network, similar to the way that you could auto-register machines' DNS suffix in your on-premises Active Directory. So what that means is when you join a domain on-premises to your Active Directory, let's say your Active Directory is contoso.com, you join a machine to that domain, let's say the machine is machine 1, then that machine gets a name of machine1.contoso.com. That's the same principle that we're talking about here. This auto registration for these Azure DNS private zones is a capability that you can take advantage of. So from an exam perspective, again, think about what type of DNS record would be used in a certain scenario, whether a record, a CNAME, MX record, and so on. Those are pretty common. But also, how do you implement automatic DNS registration in a private DNS zone? So there's a quick start down there at the bottom. I would highly recommend that you go through that, try different scenarios, try manually creating DNS records, and see what how other machines will resolve the names for those manually created records as well as those that are automatically created. Just try things out. So we've mentioned VNet peering a little bit. So VNet peering lets you connect to Azure virtual networks. There are 2 types of peering. There is regional peering, and then there's global peering. The networks that are peered leverage the Azure backbone for privacy and isolation purposes. So you can peer networks across Azure subscriptions, and you can even peer them across Azure tenants. But keep in mind that VNet peering is not transitive by default. In other words, if I have VNet A and it's connected to VNet B, and VNet B is connected to VNet C, it is not automatic that machines in VNet A can talk through VNet B to machines in VNet C. What that would require is a concept that we call gateway transit. So gateway transit is a peering property that lets one virtual network use the VPN gateway in a peered virtual network to get to another Azure virtual network or to get to an on-premises network. So the diagram that you're looking at here shows how gateway transit works with virtual network peering. In the diagram, gateway transit allows the peered virtual networks to use the Azure VPN gateway in the middle in hub RM. So that's the network that we're talking about. So because there's peering with gateway transit configured there, for example, Spoke RM would be able to talk to Spoke Classic using hub RM as the kind of facilitator for that. So connectivity that's available on the VPN gateway, so things like site-to-site, peer, point-to-site, and VNet to VNet connections applies to all three of these virtual networks. The last concept is service chaining. That's the last bullet point that we have on the slide there. So service chaining enables you to direct traffic from one virtual network to a virtual appliance or gateway in a peered network through custom or user-defined routes. If you want to set up service chaining, you would configure user-defined routes that point to virtual machines in a peered virtual network as the next hop IP address. The user-defined routes could also point to virtual network gateways in order to enable service chaining. So from an exam perspective, think about how you would answer this question. How would you determine if the client in one subnet can communicate with a client in another subnet, and I misspelled another there, based on the peering setup? So would the machines in Spoke RM be able to talk to the on-premises network site machines going through Hub RM? How would you be able to tell whether that was possible or not? Or what are the factors that would go into that answer? Azure Virtual WAN architecture. So historically, organizations used a combination of things like VPNs to provide site-to-site connections for branch offices. They would use point-to-site connections for individual remote users. And then there would be other types of connections for cloud services. Software-defined WAN technologies combine and manage the connections, which means you need connectivity appliances. So things like gateways at each of the sites, and you connect them through internet tunnels. Azure Virtual WAN combines all these methods of connectivity to enable the organization to leverage Microsoft's backbone network, which gives you options for worldwide, highly available connectivity. A virtual WAN is, in effect, a security delineation. Each instance of a virtual WAN is self-contained in terms of connectivity, and therefore it provides a measure of security isolation. So organizations typically are only going to need a single virtual WAN because there are many, many networks that are going to be part of that virtual WAN. So each virtual WAN is implemented as a hub and spoke topology. It can have one or more hubs, and it can support connectivity between different types of endpoints, including connectivity to telecom vendors. So maybe you've got connections to AT&T or Verizon or one of the other telecom vendors. That can be part of your virtual WAN. Virtual WANs and virtual hubs, which we'll talk about on the next slide, come in standard and basic SKUs. Once again, we're talking about SKUs. So as you see here in the middle, with the little blue box, the thing that I've highlighted there is that with the basic SKU for virtual WAN, the only available configuration is site-to-site VPN. So from an exam perspective, it's important to understand that the basic SKU only allows site-to-site VPN configuration. If you need to have any of the other features in your WAN, whether it's express route, point-to-site, VNet to VNet transit, those types of things. If you need any of those other things in your virtual WAN, you have to have a virtual WAN type of standard. Virtual hubs. So a secured virtual hub is an Azure virtual WAN hub that has security and routing policies configured using Azure Firewall Manager. You can use a secured virtual hub to filter traffic between virtual networks and branch offices, and to filter traffic that's going outbound to the internet. A secured virtual hub also provides automated routing capabilities. The routing capabilities in a virtual hub are provided by a router that manages all the routing between your gateways using Border Gateway Protocol, or BGP. The router also provides transit connectivity between virtual networks that connect to that virtual hub. And again, there are basic and standard SKUs for virtual WAN and the capabilities that I described just a moment ago. These apply to the standard, not the basic, SKU. So the basic SKU is very basic. The standard is more likely what you would use in an enterprise environment. One of the benefits of Azure Virtual WAN is the ability to support reliable connections from many different technologies, whether you're talking about Microsoft-based technologies like ExpressRoute or a VPN gateway, or if you're talking about devices that come from a networking partner like Barracuda or Cisco or VMware. If you get devices from those networking partners, those types of devices are known as Network Virtual Appliances, or NVAs is the acronym. NVAs are deployed directly into a virtual WAN hub, and they have an externally facing public IP address. This allows customers who want to connect their branch equipment to the same brand or same vendor of NVA in the virtual hub to take advantage of some of the more proprietary end-to-end SD-WAN capabilities. Once virtual networks are connected to the virtual hub, NVAs enable transitive connectivity through the organization's virtual WAN. Now, one thing that's very important, from a pricing and scaling perspective, you need to understand the concept of scale units and connection units. So a scale unit, which is described in the box in the lower right, a scale unit provides a unit for aggregate capacity of site-to-site, point-to-site, and express route within a virtual hub. So one site-to-site VPN scale unit, as an example, provides a total capacity of 500 megabits per second. One express route scale unit provides a total capacity of 2 gigabits per second, right? So each of those scale units it factors into the cost that you're going to be responsible for your WAN. A connection unit applies to any on-premises non-Microsoft endpoint that is connecting to an Azure gateway. So that means different things in different scenarios. If you're talking about a site-to-site VPN, this means how many branches are involved. If you're talking about a point-to-site VPN, right? Remember the point-to-site is client computer to a site. That means how many remote users are involved. If you're talking about ExpressRoute, it means the number of ExpressRoute circuit connections. So from an exam perspective, make sure you know how to calculate the number of connection units or scale units that an architecture will require in a given scenario. So make sure you understand how those connection units are determined and how scale units are determined. Remember that scale units talk about bandwidth, connection units talk about how many things are connecting to Azure, whether it's a branch, a user, or a circuit. And that brings us to the end of this section. I hope it was beneficial for you. Please be sure to check out the study guides from Thomas Maurer and Charbel Nemnom as well. And you have the links to the study guide, the deck. So be sure to check out the other videos in this series. and I hope you do well on the exam.